Hello everyone, welcome to lesson 13, and as usual I went ahead and put in the comments at the first of the program, your name, your program description. This is introduction to loops, and then the date. Let's see, I should have added lesson 13. There we go. Alright, so we have our two include statements or header files. We're using input-output stream, and we're using string. Now I'm not going to show you everything I have here in this program. I only want to show you this very first one. This is the for loop that I'm going to discuss right now. And what I've done, I've started the for loop and I start my integer a, so I'm declaring my variable a as an integer right here. And then I'm setting its value or initializing it at 10. So it's starting at 10. And then I check in my loop to see if a is greater than or equal to 0. Okay, so greater than or equal to 0, that means as long as it's true, as long as it's greater than or equal to 0, the loop will keep going. And then I have a equal a minus 1, okay? And so that means it starts at 10, so when I finish the first round of the loop, I subtract 1 and then it becomes 9. Now if you look at the body of the for loop when it's true, see the braces that make all these statements count as if they're one, it groups them together. See out a, so it'll print the 10 the first time through. If a is equal to, remember you have to have two equal signs to check to see if two things are the same. Otherwise you'll assign that value to a if you only have one equal sign. So if a is equal to 0, which it's not, it's 10, we won't see out boom. So that will not happen because a is 10, it's not equal to 0. So we go back up. Well, now we subtract 1 because we finished the loop, so now 1 will be subtracted from a. Now a is 9. Is 9 greater than or equal to 0? It is. So then we see out 9. It's still not equal to 0, so we subtract 1 and now it's 8, etc. until of course a will eventually equal 0 and we get boom. So what I want to do is just show you how this will react when I run it. So let me show you. So there it is, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, boom. So that is an example of how you can use a for statement. Of course, when you have assignments, they're a little more complex than this, but it gives you the idea of what you can do inside the braces during the loop. And then, of course, you'll have more coding outside of the loop. So let's move on this lesson and talk about what I have next. Okay, as you can see, I paused the video and then I commented out our little program that we just did. Now, I want you to put this in your text editor and run it through the compiler and see it actually work. I want you to find your mistakes when you make typing errors. I want you to change it up and make it do different things. This is how you learn. Okay, so next, I've commented this out so we can do another program. And let me scroll down here and discuss the next program. This program can create all possible 4-digit PIN numbers. So believe it or not, you could write a program that could figure out all possible PINs if you have 4 digits. So the least possible PIN is all 0s, and of course the greatest would be all 9s. What I've done here is I have used all for loops, and they're nested for loops, so one inside another, inside another, inside another, and then we're printing out all those values. Now what happens, you have a for, integer a is 0, so it starts at 0. If a is less than or equal to 9, add 1 to a, and it goes okay. So it goes to the next line, and that's another for statement. For b equals 0, b is less than or equal to 9, add 1 to b. Okay, then it does the same for c, and then it does the same for d. Well, how this works is that this one, the furthest most nested one, I guess the way to put that, the most nested one would be the one that would complete first. So for D is equal to 0, D is less than or equal to 9, add 1 to D. So it'll start counting. All these will remain 0 because they're all zeroed. And it'll count this. Well, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Once that loop has finished, it'll do this loop once. Okay? It'll do this loop all the way through, like all the way to 9. So this one will then be counting, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, with this one counting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it moves up again. So this will go kind of like your odometer on your car. And so, you know, the next digit over doesn't move up until the one before it, the one on the right, does 9 times. All right, so that's kind of how this works. So what I want you to do is type this in, and then I want you to run it and see if you can make it count all the way through from 0000 to 9999. And you'll see what I'm saying. So this would count all the way to 9. Then this would become a 1, and then it would be like 1 0 1 1 1 2 1 3 4 1 4 1 5 1 6 1 7 1 8 1 9, and then this would become a 2. 2 0 2 1, and once this hits 9, guess what happens to this one? Then it starts. Okay, so this loop would finish around, then this would do around, and then this one would do all the way through 9, then this would do around again, and all the way through 9, and this one will keep doing until it gets to 9, and then this one would start, then this would count to 9, then this would count to 9, and then this one would go to the next one, and so on. And so when you run this, you'll actually get a chance to see how these nested loops actually operate. So I want you to type this in and then practice and play with it and just get a feel for how the nested loops will react when you run them. Okay, so the next section I'm going to talk about a few notes on some other loops. Okay, so now we have a section notes on loops, and so here's where we did our nested for loop. And then here's a few notes, and you need to be typing these in so you can study them. All right, so in programming, we need some way to keep our program going until some kind of condition is met. So we use loops in our programs to keep the program active. We have 3 different types of loops that we use this semester. We have the for loop, the while loop, and the do while loop. Okay, there are several ways we can control the while loop, which if you watch the Chapter 5 review videos, you learn about those. All 3 loops have the same basic principle where they have a starting point, an ending point, and it means a means to reach the ending point. So let's look at this for loop for an example. For loop example where I will count from 1 to 5. And here's our for loop. For integer a equals 1, so that's letter A. This is the starting point. This is the value in which our program will begin counting from. So in this case, it's starting with 1. You could start with any value you want, but in this case, we start with 1. Then B, the letter above it, A is less than or equal to 5. This is the exit condition, the stopping point. This is where our program will stop counting. Rather, it counts to that value. So this is where we're checking, right? Is it true or false? If it's true, the loop continues. If it's false, the loop stops. And then C, this is the value we want to program the program to count by. I need to change that. Little mistake there, T-H-E, there we go. We want the program to count by. So this is, are we adding 1 each time it goes through the loop? Or do we add 5, 20, 100? You know, it's totally up to you and how you're programming your code. So, you know, that's all going to be on you, how you design your loops and how you control them. But these are everything that you need. Your starting point, what you're checking for to stop the loop, and then how are you going to get there? Are you going to add 5 or add 1, subtract 10? That's all up according to how you design your program. All right, so here's a while loop. So let's see if we can find those 3 things in a while loop. So first we would need a starting point. Where's our starting point? Right here, integer b equals 1. So outside of the loop itself, we say, look, here's what we start with, a 1. Okay, and we declared the variable's b, and we declare it, and then we say it's equal to 1. All right, so where's the next piece? The next piece said this is the exit condition. Well, with the while loop, the exit condition's right here. B is less than or equal to 5. And then where do we increment or change the value? See, the value we want the program to count by. Here it is. We put it inside of the actual loop itself, okay? Now let's look at this. Integer b equals 1, while b is less than or equal to 5. So we print out a b, then we add 1 to b. Now b is 2, it prints out a 2, etc. Okay? So here's our output down here. 1, 2, 3, 4, 5, because we even had, you know, an end line there, so it'd all be on a separate line. But here's a do while loop. Same thing. Here we initiate, we declare our variable, and we initialize it with a 1, so we're doing the same thing. But then we have a do here. Here's the body of what we want to happen inside the loop, the part that repeats, and here's our while. Here's where our check is to see if we stop the program or not, right? Right here. But look, we already did this part first. So no matter what you do, the do while loop is always going to execute at least once, because you don't check to see what the value is until at the end, until after you've done the loop once. Then you check. With the while loop, you check first up here, and then you do your loop. Here, you do at least one loop and then check. So the do while loop will always execute at least once. And here's the output. That's the end of this lesson. I hope you pause it and type in some of these programs and practice, because it's good for you and you'll learn more than ever. All right, talk to you next time.